Today, we would like to introduce to you about our prototypes from case study 3, the Smart Wheelchair System. Our title is Unaided Supervision Chair. Let's start. My name is Lam Xiaohui. I would like to introduce some about our prototypes. Many people around the world are suffering from mobility impairment, typically because of aging, arthritis, stroke, or spinal cord injury after an accident or falls. So by the inventions of wheelchair, it actually provides a chance for these people to move around freely, to carry out their daily routines, instead of always remaining at the same positions to wait for the help from caregiver. So, to meet the demands of wheelchair users, there are typically two types of wheelchair available in the markets. First is the electric powered wheelchairs, and the second is the conventional manual wheelchair. So for patients with paraplegia, which their arm functions are well, they are recommended to use the conventional manual wheelchair because this can help them to train their arm strength. But for the quadriplegia patients, they are advised to use the electrical powered wheelchairs because they have no enough arm strength to propel themselves using a manual wheelchair. So by conducting a survey among 15 respondents, we found that 60% of the wheelchair users are male, while 47% of the caregivers are females. So by considering the difficulty of the female caregiver to carry or support the wheelchair user in and out from the wheelchair, we had developed our motivations to design a wheelchair that has the shifting and lifting functions.
I would like to explain the problem faced by the provisional wheelchair user. First of all, the user requires extra help from their caregiver or family to enter and out of their car. About 67% of users stated that they are not able to enter the car on their own from our survey. Second, the user also requires help monitoring system, and about 80% of users from our survey said so. Third, 73% of users are not able to go out on their own. This is due to some serious injuries. And lastly, the user also are facing difficulties in handling the wheelchair due to some injuries.
I'm Tan from Group 7. Today I would like to present about the objective of this project. So first of the objective that we are concerned about is to develop electrical power wheelchair that is able to transfer the wheelchair user between the wheelchair and the car. Second, to implement global positioning system which is known as GPS, tracking system to locate the user's location through IoT which is known as Internet of Things. And lastly, to develop a monitoring system on wheelchair that continuously monitor vital signs of the wheelchair user and can be accessed by caregiver through IoT which is known as Internet of Things.
Hi everyone, my name is Ahmad Amirul Nizam bin Zulkifli. Okay, now I will continue for the methodology of the project. Okay, for the flowchart of the project, we start with research on existing wheelchair in the market, and then we identify the problem statement based on we conduct the survey and interview the user. From there, we define the objective and scope, and then we do a market survey and graphical analysis. From there, we identify the customer requirement, what customer need and engineering characteristic, and then we generate the schematic diagram of the prototype. Besides that, we do a conceptual design and analysis the wheelchair, and then we analysis the device based on calculation and then simulation. Then we do a component purchasing, mean we buy all electronic part and we assemble the component and testing. So if functioning of the prototype is well, it means the end of the project. If not, we will troubleshoot again hardware and software, and then we test again, and then if the prototype functioning well, is the end. Okay, next I will show you about prototype design. Okay, for the prototype design, we separate for the two parts with hardware and software. For the hardware, we have a mechanical part and electronic part. For the mechanical part, we use a conventional wheelchair to modify to attach the brushless DC motor. Okay, we also use a jet lift as a lifting system. We use a roll and rail for the shifting system. Okay, for the electronic part, we use Arduino Mega 2560 and Not MCU ESP8266 as a microcontroller to control all systems. And then we use input source like vital sign sensor, like heart rate sensor and body temperature sensor to monitor the vital sign of the user. We also use a joystick for the movement, emergency button for emergency case if user have a problem, and then we use a switch push button for the shifting and lift. Okay, we have a GPS module as a tracking system to track the user when they have a problem. And then for the output of the microcontroller, we have a power window motor to control the shifting of wheelchair, and power window motor also to control the lifting system. And then we have a brushless motor to control the movement. Wheelchair, we connect with a battery 24 volt to operate all system. Next, we continue to the software. Software that we use is a Blink software. Blink software is a IoT platform to collect data from any input source. Okay, we use a GPS and vital sign and push emergency button to monitor the user from far. Okay, from that we can know the user at where location if any problem.
Assalamualaikum and hi, my name is Faiza and I will explain about the result of our prototype. There are a lot of advantages for our prototype. First, the user able to move itself by using the joystick without any help of caregiver or medical personnel. Secondly, user able to enter into the car with a less consumption of energy. Third, the medical personnel and also caregiver able to monitor the health of the user and track the position of the user by using the GPS. All of these advantages cost only 1,855 ringgit. That I believe it is way much cheaper compared to the electric motor wheelchair that existed in the market. For comparison, JZ Air 2 that manufactured from Quantum Rehab Enterprise. This electric wheelchair have advanced features such as long-lasting battery, can elevate until 14.4 km per hour, and also have lifting system. Unfortunately, JZ Air 2 costs up to the 20,000 ringgit that I believe it is so extortionate.
Saya merupakan pesakit paraplegia yang menyebabkan lumpuh separuh badan setelah 22 tahun. Tengok apa prototype yang daripada Unimap yang dinamakan Movis. Saya rasa sangat-sangat sesuai lah untuk yang paraplegia yang mungkin ada masalah lemah tangan juga, ataupun senang kita yang tetraplegia yang memang sememangnya lemah. Jadi kalau yang tangan lemah, saya rasa memang sangat-sangat sesuai. Maksudnya dia akan levelkan tinggi sama pada dengan kursi, dan kita duduk kat sini dia akan ganjak sini dan senang kita untuk transfer. Jadi saya rasa memang agak sesuai jika sekiranya diketengahkan produk ni. Memang saya rasa memang sangat-sangat membantu untuk OHU yang terutamanya tetraplegia yang ada masalah kaki dan tangan untuk transfer.